Section 9.2 is on parabolas. The definition of a parabola is the set of all points in a plane that are equidistant from a given point, which is called the focus, and a given line, which is called the directrix. So here's a couple examples of the way a parabola can look. A parabola can be opening upward, and the point inside here is the focus, and the line out here is the directrix. Parabola can be opening downward, and again the focus is inside with the directrix above the curve. It can be opening to the right, or it can be opening to the left. For the purpose of this video, we're only going to be focusing on parabolas that open up or down. The equation of a parabola that opens up or down is y equals a times the quantity x minus h squared plus k, where the vertex is hk, and the equation of the axis of symmetry is x equals h. That is a vertical line that goes through the vertex about which the parabola is symmetric. The coordinates of the focus are h, comma, k plus 1 over 4a, and the equation of the directrix is the line y equals k minus 1 over 4a, and the length of the latus rectum, and that's a segment that goes through the focus that is perpendicular to the axis of symmetry. So it goes through that point, which is the focus, to each side of the parabola. The length of that segment is the absolute value of 1 over a. If a is positive, the parabola opens upward. If a is negative, the parabola opens downward. Now the general form of a parabola you probably recognize from Algebra 1 is y equals ax squared plus bx plus c. And the standard form of a parabola, which is vertex form, which we actually saw earlier in this course, is y equals a times the quantity x minus h squared plus k. So let's take a look at a couple examples here. For each parabola, we need to write it in standard form. Then we're going to identify the vertex, the focus, the equations of the axis of symmetry and the directrix, the direction of opening, and the length of the latus rectum. First thing we'll do is write it into standard form. So I'm going to take my x squared plus 2, put that in parentheses, and put my negative 3 out here. Because what I basically need to do is to complete the square. I need to make this a perfect square trinomial so that I can factor it into x plus or minus something in the parentheses squared. So if you remember how we did this in Algebra 1 and earlier in this course, we take half of b, which is the coefficient of x, and we square that and add it to make this a trinomial. So my b is 2, half of that is 1, 1 squared is 1. So I'll add a 1 here, but since I added 1 to this equation, normally what I would do is add 1 to the other side, but I want to leave y all by itself here. So if I add 1 to the right of the equal sign, I can subtract 1, and that basically cancels it out. So I haven't changed the equation at all. Now, factor that trinomial. So that's going to factor into x plus 1 squared minus 4. So my h is negative 1, and my k is negative 4. Remember, this is x minus h, so h has to be a negative 1 plus k. So that means that my vertex is going to be the point negative 1, negative 4. My focus, and remember the equation for the focus is h, so it keeps that h, and it adds to it 1 over 4a. Well, for this equation, a is equal to 1, so 1 over 4 times a is just 1/4. So I need to add 1/4 to my k, so the coordinates of my focus. Oh, that's right, it's a negative 4, so plus a 1/4 is going to give me a negative 3 3/4. The axis of symmetry is the line x equals h, so x equals negative 1. The equation of the directrix is y equals k minus 1 over 4, and so that's 1/4, my a over here, so that's going to be y equals negative 4 and 1/4. My latus rectum, the length of that segment that goes through the focus to either side of the parabola, is the absolute value of 1 over a, and so that's going to be 1. And my parabola, since a is positive, my parabola opens up. Okay, now let's graph this. To do that, I'm going to go to my calculator and put the equation in and use some points. Well, actually, I can actually start a little bit already here. I know that my vertex is going to be at the point -1, -4. So I think I'll go ahead and graph that. -1, -4, that's my vertex. And remember, when we make a table with a parabola, you want to make sure that that's the center value in the table. So -1, -4. And I'll use my calculator to help me do the rest of the work here. So I'm going to put this in. I can either put this in standard form or in general form. I think it's going to look easier if I do it as x squared plus 2x minus 3 and graph that. And that makes sense. It looks like my vertex is at the point -1, -4. So I will use my table function and do two values smaller than -1. So I'll start with -3, -2, -1 for my vertex, and then 0 and 1. So that gives me the y values of 0, -3, -4, -3, and 0. So 0, -3, -4, -3, and 0. And that was for -2, -3, 0, and 1. So let's graph those points. -3, 0, -2, -3, 0, -3, and 1, 0. And there's my parabola. For our second example here, gets a little more complicated. I have the equation y equals -1/8 x squared minus 3/4 x plus 23/8. And on the surface it looks absolutely horrible, but believe me, the vertex of this one is going to turn out to be not such a bad number. So let's go ahead and complete the square to write this in standard form. To do that, I can't have any coefficient of x squared. So I need to factor a 1/8 out of my first two terms. So factoring it out of the first term is very easy. Factoring it out of 3/4, I'm basically saying, what is 3/4 divided by 1/8? And if you can't figure out what that is, just use your calculator. Do parentheses 3 divided by 4, close parentheses, divided by 1 divided by 8. And you'll get that since that's a negative divided by a negative, it's a positive 6x. And then let's put our plus 23/8 out here. Now complete the square. Take half of b and square that. So that's going to be a 9. But I didn't really add 9. I really added 9 multiplied by this -1/8 out here. So what I really did was, instead of adding 9, I really subtracted 9/8. So if I subtract 9/8, I need to add 9/8 on the same side of the equal sign. So I have -1/8, and then factor this trinomial. That's going to factor into x plus 3 squared, and 23 plus 9 is going to give me 32 over 8, or plus 4. Now I can see that my h is -3, because remember that's x minus h, and my k is 4. So my vertex is -3, 4. My axis of symmetry, the line about which this is symmetric, is the line x equals -3, works off of whatever the x of your vertex is, whatever h is. My focus, let's see, so I need to calculate 1 over 4a. So 1 over 4a is going to give me 1 over 4 times -1/8, because that's what my a is, or 1 over a -1/2, which is the same as 2, -2. So my focus is going to be -3, and then plus -2, giving me a +2 for my focus. My directrix is the line y equals k minus that number. So that's going to be the line y equals 6. My lattice rectum, the length of my lattice rectum is going to be 8, because remember that's the absolute value of 1 over 4a. I'm sorry, 1 over a, not 4a. Or the absolute value of 1 over -1/8, which is the absolute value of -8, which is 8. So the length of my lattice rectum is 8. And this one is going to open downward because A is negative, a -1/8. So let's go ahead and graph this. So my vertex is -3, 4. So I'll start by graphing that. -3, 4. Okay. And I think I'll go ahead and start making my table here. So I have -3, 4, and I'll choose points. I think these will work: -4, -5, -2, and -1. And let's graph that in the calculator. And actually, I'm thinking this one might be a little bit easier to graph in standard form. So I'm going to be very careful with my parentheses. So here's my -1/8 times, and then I had x plus 3 squared and plus 4. I wanted to avoid all of those fractions that I had with the original equation that I had. And that looks about right. My vertex was at the point -3, 4. Okay, so let's take a look at our table. And I believe I had chosen the points. Where did I start with? -5. So -5, -4. Ooh, let's see. I don't like that one. Let's see. I think if I do, let me start my table. Let me change my table a little bit here. I'm going to start with -7. That's better. -5, -3. There's my vertex. -1. That's not so bad. And a +1. Okay. I don't mind those numbers. I can actually go ahead and graph those halves. But I really didn't like having the other ones. So I'll go over here and change my table a little bit. So I still had -3, and I had -5, -7, -1, and 1. And that gave me 2, and 3.5, and 3.5, and 2. And let's graph those. So -7, 2, 4, 6, 7, and a +2. -5 and 3.5. -1 and 3.5, and 1, 2. So as you can see, this parabola opens downward, and actually it's a little bit wider than our standard parabola. And going back to talking about the table here, please do pick values that are going to give you nice numbers. You should be able to graph 1/2, but try a variety of x's until you get something that actually works. So in this lesson, we took a look at what a parabola is, set of all points in a plane that are equidistant from a given point and a given line. We focused entirely on opening upwards and downwards parabolas with their equation in standard form and all of the details. We went ahead and wrote it in standard form, found the vertex, the focus, the axis of symmetry, the directrix, the lattice rectum, the direction of opening, and then went ahead and graphed one.